name is Patrick Rainey, and I am the W.R. Meadows architectural specialist for Northern California, Northern Nevada, and the Pacific Northwest. And obviously, I want to thank all of you for taking the time to be a part of the presentation today. And I certainly hope that the information we're sharing today will be helpful to all of you. So, and I know that many of you are likely familiar with our company, or maybe you've attended some of our virtual presentations in the past. But for those of you who aren't as familiar, let me share a little information about our company before we get into the meat of the presentation. So the W.R. Meadows Company started in 1926 in Elgin, Illinois, and our company is family owned and operated to this day. And we're very excited that in just a few short years, we'll be reaching our 100th anniversary, which of course we're very excited about. We're now headquartered in Hampshire, Illinois, and we currently have 13 manufacturing facilities and 4 warehouses strategically located around North America, and that includes Blue Ridge Fiberboard, which is a part of the W.R. Meadows family now. And also our DecoSeal division, which supplies a number of products specifically for the pool industry. And lastly, I just wanted to mention a couple of exciting developments that have taken place. First, we started 2022 last year by acquiring the Gemite company based in Canada, which produces positive and negative side waterproofing products, as well as a number of specialty liquid products. And secondly, we recently opened our new Learning and Innovation Center at our corporate facility in Hampshire, Illinois, within the last year or so. And that now gives us a much greater ability to develop new products and technologies, as well as greater and enhanced testing capabilities. So we have a lot of exciting things going on within our company. Here's a map of our various locations just to kind of give you an idea geographically of where we have locations to serve you in the US and Canada. But I also want to mention that our products are available worldwide. So wherever you may have a project, we can certainly be of help. We started with one product back in 1926, which was asphalt expansion joint. We now offer over 300 products to help protect your design structures, from our Division 3 offerings that include expansion joint materials, to structural and surface concrete repair materials, epoxies and grouts, to our liquids line that includes curing compounds, curing and sealing compounds, and sealers for decorative concrete, to joint sealants. And then our Division 7 products, starting with underslab vapor barriers and retarders, to air, water, and vapor barriers for above-grade applications, to our below-grade waterproofing systems, and with the soundproofing and insulation board products from Blue Ridge, we really have a full line of products to help in protecting the building envelope. So again, these subsidiaries are all part of the W.R. Meadows family, and with each of their logos represented here, just to give you a quick snapshot. So let's get into today's presentation topic, which of course is polished concrete floors. And as Isaac mentioned earlier, this is an accredited AIA presentation. So all of you folks, registered architects, will be able to collect a learning point for it. So we just want to see an overview of polished concrete today and understand that the process not only incorporates the grinding and polishing procedure, but also the equipment involved and the fact that there is a concrete densifier used during the process. And as far as the benefits of polished concrete, we will be discussing this more in depth later in the presentation as to why polished concrete is a very advantageous system. So polished concrete is a practical, decorative, and economical floor system for any facility. And it's really become one of the fastest growing systems to ever hit the flooring industry. So we need to understand that this is a multi-step mechanical grinding and polishing process that utilizes tooling that consists of industrial diamonds, and also critical to the success of this process is the application of a concrete densifier to help level, densify, polish, and finally seal the floor from within the interior of the floor surface. And again, we'll elaborate on all of this as we go along here today. So where can it be used? Well, the answer is just about anywhere, right? Well, as we can see from the slide here, and we've all seen polished concrete floors in many of these environments, even if we didn't realize it. And we'll look at several of these applications as we move forward. So this looks like a manufacturing or warehouse facility. And notice the appearance on either side of that middle traffic area. So in this case, that middle area has been polished, and the area on either side, or the areas rather on either side, have not yet been done. So what will likely be happening here is that those two areas will get done when the facility is closed, or they can temporarily shut down and shut those areas off and take them offline. And this is a good example of the fact that to do the polishing process, you don't have to shut down a facility. It can be done one area at a time so that the facility can remain open and operational. Another good example here is a cafeteria. Note the fact that there is some color incorporated in this floor, and there are various coloring techniques when it comes to polished concrete floors that we'll discuss further in the presentation. One other thing to notice here is the light reflectivity. We can see the lights from above reflecting from our floor, and this is another benefit of polishing that we will discuss later on as well. Here's a shot of an auto dealership showroom floor. This has become very popular in recent years since it combines high aesthetic value with a very practical and low maintenance floor. And as we mentioned earlier, one of the many applications is residential, and here we have a garage floor. In fact, this is the garage floor of one of our good WR Meadows colleagues back in the Chicago area. And again, the benefits are very much the same as we saw in the last few slides. And in this case, the polished floor will stand up well to the heavy truck and boat and to any tire marks as well. This looks like a restaurant entryway. And again, note the coloring of the floor. This is a really nice example of what a flooring contractor can do with using different colors and shapes. This is a race facility. I can tell by the race car in the background there. This is located actually in southern South Carolina, and turned out to be about a 34,000 square foot project. And again, notice the amount of light reflectance going on here. So now that we've discussed what polished concrete is, where did it originate? Well, the process was discovered in Tunisia by a contractor that worked with granite and marble. And typically, this process used a wet grind system, and the contractor had tried the same process on concrete and found that he was able to get a great polish on the concrete. And this was noticed by one of the royals in Tunisia that had asked the contractor to do some polished concrete in the palace. Well, being short-staffed, he hired some laborers to do the work, and there was one major mistake. They had polished the concrete dry. However, the appearance of the floor was fantastic, and this was relayed by the contractor to the company he had purchased the equipment from, which was HTC out of Sweden. Well, it was from this that the process of dry polished concrete really originated. It was a big mistake, and it turned out very well. So the process was introduced to North America by a company called Vic International in the early 1990s. And I was fortunate enough to go along with several of my WR Meadows colleagues to do hands-on training a number of years ago at their facility in Tennessee. And the photos coming up shortly show the same equipment that we trained on. So here are some examples of one type of equipment on the market. The first being the main piece of equipment, the grinding machine, which is on the left. This is the machine that I was able to train on. And these machines usually have 3 or 4 heads with typically 3 to 8 diamond segments on each head. The machines rotate at approximately 350 to 1400 RPMs and is variable based on the type of concrete and the diamond grit being used during the pass. The two other units we see here are the pre-separator and the vacuum. And these two pieces are attached to the grinding machine and are used to remove the majority of the waste and dust from grinding the floor. And it enables the control of airborne dust as well as contaminants. This is the reason we can work on a floor without having to completely close down a facility, which we saw in one of the earlier slides. And using the dry process allows the dry waste material or powder to either be safely disposed of or recycled. So this is a much cleaner process than wet grinding, which still exists, but again, for obvious reasons, is usually not the preferred method. We mentioned earlier that this is a multi-step mechanical grinding and polishing process. And a true grinding and polishing system can range from a 5 to 10-step process, depending on the floor's design and also the original condition of the floor. Here are photos of the tooling that is used with the equipment to obtain the level of grind and polish that is desired with the floor. So first, we have the diamond grinding segments or metal bonds that are used for grinding. These are industrial grade diamonds and are suspended in metal. And they range from 16 to 150 grit segments and are used in the grinding phases of the process. Now, this process is used to remove high spots in the concrete, as well as imperfections and contaminants, such as cures and seals, mastics, or other types of chemicals. The diamond polishing pads or resin bonds that we see here are used for the polishing. And these diamonds are suspended in resin to provide a higher grit and range from 100 to 3,000 grit and are used for the actual polishing part of the process. And the idea of the process incorporates different grit levels of these pads, going from a lower grit, which is more aggressive, to a higher grit. And each of these pads will scratch the floor and leave these scratches. But moving to a higher grit pad removes that scratch pattern from the previous pad. So really the best explanation of this process is to compare it to sanding a piece of wood. So to finish or flatten the wood, a rougher sandpaper, i.e. a low grit sandpaper, would be used to sand the wood first, and a smoother sandpaper or higher grit is then used to actually finish the wood, which at the same time also removes the scratches from the wood. So this is the concept of how the process works with polishing. So before we even start the process, a few factors should be addressed to ensure that we get the best finish of the floor that we possibly can. It's always recommended that a mock-up be done because this process is extremely difficult to predict the actual finish of the floor. As you know, all pours are different and all finishing techniques are different. So these factors will affect the final appearance of the floor. And frankly, no two floors will be exactly the same. So we always want to be sure that the floor is clean and dry with no contaminants present and that the slab is at least 28 days old. The concrete needs to have a minimum compressive strength of 3,500 psi. A softer concrete can diminish the working life of the diamond tooling, which of course means we would need more diamond segments to complete the job, which adds to the cost. And we could potentially have damage to the floor as well. And again, as we talked about earlier, the polishing process is a dry process, and it's important to understand that with a dry process, there is substantially less waste. As you will see, there are many passes over the same piece of floor, and with a wet process, each pass will result in a slurry on top of the concrete that would need to be cleaned prior to the next step. We do have a list of certified applicators familiar with our system that we can provide. However, that doesn't mean there aren't a lot of good, qualified, and experienced polishing contractors out there. So do your due diligence when checking out polishing contractors as you would with any other contractor. So as we mentioned earlier, the grinding process incorporates the metal bonded segments with different grit ranges. And this is done to prep the floor prior to the polishing phase. And this phase accounts for about 60 to 65% of the total labor time of the process. This grinding phase is essential to a successful polished floor system. If it's not done properly, it will be apparent in the final product. And in the following slides, we'll see an example of the typical steps used on an exposed concrete floor that has no contaminants on it. And the first step shown here in this photo involves a grind using an 80 grit metal bond. If the exposure of aggregate is not apparent at the initial depth set by the grinding machine, another pass can be done using the same metal bond, or alternatively, a lower grit metal bond can be used. So this is typically the second step, moving to 150 grit segment. And notice in this photo, we can see that the pre-separator and the vacuum are attached to the grinding machine. And as we talked about a little earlier. And I have actually trained on this particular grinding machine and gone through all the steps that we're talking about today. And it was a great experience, really, to be able to do this hands-on and see firsthand why it takes so many steps to really get this right. And I was surprised how much you can actually feel the high spots in the slab as you're pushing, this grinding machine over it, and how much the floor flattens out with each pass. And this is something we will circle back to and address a little later as well. So at this point, we have finished the grinding part of the process, and the next step involves the densification process. So why do we need a densifier? Well, it's possible to polish concrete without the use of a densifier. However, proper application of a densifier increases the longevity of the floor. And of course, we want our floor to last as long as possible, right? So including this one additional step of applying a densifier at this point just makes sense. And a properly densified floor will increase the abrasion resistance of the floor and make the floor more scratch resistant. And this scratch resistance will help to maintain the shine. And, there are different schools of thought as to when the densifier should be applied, but the best penetration happens when the densifier is applied between the grinding and polishing phases of the process, as we see here, because this is the point at which the slab is most open or porous. So it's at this point that we can get the deepest penetration of our densifier into the slab. So how does the densifier work? Well, typically the densifiers are sodium silicate or lithium silicate in nature. When a silicate is applied to concrete, it reacts immediately with both hydrated lime and free lime to form dicalcium and tricalcium silicate compounds. And these compounds then react with water to form calcium silicate hydrate, also known as CSH gel. Chemical hardening and densification of the concrete occurs due to an increase of the CHS gel, which fills the pores or voids in the concrete. The CSH gets produced in the pores. The CSH gel produced in the pores is also insoluble in water, making the concrete highly resistant to water, acids, and numerous other chemicals. And if you happen to forget all the chemistry, the simplest explanation I've ever heard is this: the densifier turns the bad stuff in concrete into good stuff. So if all else fails, just remember that. So this densification of the slab is intended to be a one-time application. And being a chemical reaction, this process takes some time. So it's important to understand that the abrasion and stain resistance are not immediate. And as we discussed earlier, the abrasion resistance protects the integrity of the floor and allows longevity of light reflectivity and shine. And we always want to be sure our floor is dry for at least 24 hours before we move on to the last stage of the process that we'll talk about next, which is polishing. So now we've let our floor dry for at least 24 hours, and we're ready to start the first step of the polishing process with our 100 grit resin bond. And notice that we're still using the same grinding machine that we started with in step one. So here we see our next polishing step at 200 grit. But notice something is starting to happen here. We can just start to see the scratch patterns in the surface that we had talked about earlier, and just a little bit of light reflectivity as well. Now, when I trained on this process, I have to admit, I was starting to wonder how long it was going to take to actually see something change in the appearance. And it was at this point that I had my aha moment. It took a little while to get there, but at this point, you can at least start to see what we've been talking about. So now we get to step 6, which is our 400 grit resin bond pad. And this is the point at which we can talk about incorporating colors with the concrete. Now, there's obviously the option of adding integral color to the concrete at the batch plant, which will give us a uniform color throughout the slab. Another option is shake-on colors, but these can be somewhat difficult to use as the color can be affected during the grinding phase. And since the aggregate used in these products can be high strength, it can provide harder and softer spots on the concrete that can cause divots in the floor and removal of the color. And, we often get asked about acid stains, but these products compete with the densifier for the free lime in the concrete. So these are not really a great choice. However, the use of concrete dyes seems to work very well in a polished concrete floor system and are typically applied following this polishing phase. And there are quite a range of colors and intensities of these products available on the market now. And the applicator needs to make sure that the color is thoroughly washed and is completely dry prior to continuing on to the next polishing step. So at this point, we can start to see an actual polish or shine on the floor. And this is considered to be the first, quote, finish option with most polishing systems, and is typically referred to as a satin or low gloss finish. And at this stage, we can still see some of the swirl marks, but still a good appearance. Here is another finish step, which would be considered a semi-gloss finish. But notice at this point, we really can't see any of those swirl marks anymore. And now we can even see the grinding machine label reflecting off the floor. So here we are finally at the final step in the polishing process, 3000 grit, which is a high gloss finish. And folks, this is as good as it gets. We really can't do any better than what you're seeing right here. So now we're going to talk about the products that are available to address initial sealing of the slab after the polishing process. This slide shows us some of the types of products that are available on the market. But why do we need to do this? Well, the main reason these products are used is the fact that the densification process takes time, which goes back to what we talked about earlier when we said that applying the densifier causes a chemical reaction in the slab and that this process takes some time. But many owners want immediate stain resistance of the slab, right? And without putting a sealer or a protective coating on the slab, we won't have that stain resistance we are looking for until that chemical reaction has completed. So having a sealer applied directly after the final polishing step will allow the owner to have this immediate stain resistance once the polishing process is complete. And this will also help to protect the slab as other trades come onto this floor to do their work. So just to recap the finishes we've already seen, we have 800 grit, which is our satin finish. Then we have 1500 grit, which is our semi-gloss finish. And finally, we get to 3000 grit, which is our high gloss finish. And notice that with each subsequent step, the light reflectivity increases as well. So I love this photo because now we can see a side-by-side comparison of the three types of finishes: satin, semi-gloss, and high gloss. And another way you could look at this is in terms of good, better, best. And keep in mind that you are able to specify which finish you want on your project. This is a specifiable system, and not all projects will require a high gloss finish. And of course, with each additional step, the cost increases. So the good news is that you can choose the option that is best suited for that particular project. So now that we've talked about the equipment, we've discussed the process and the types of finishes, let's talk about the benefits of polished concrete, some of which we've already touched on. The first is the elimination of dusting of the concrete. The use of the densifier and the reaction of the silicate with the free lime helps with this. Once the pores are filled or blocked with CSH gel, migration of moisture up through the slab is also decreased, and this decrease in moisture migration greatly decreases the amount of efflorescence forming on the surface of the slab. Otherwise, specialty floor system failures involving epoxies, urethanes, or VCT floor adhesives can occur as a result of free lime being driven to the surface due to ground source vapor. Our densified concrete floor provides a water and stain resistant surface. And although the main purpose of the densifier is abrasion resistance, the sealing and chemical resistance aspects are, are excellent byproducts. Since, as we've already learned, the chemical reaction takes time to develop, and one optional further step to provide immediate protection to the application of a topical or penetrating agent, which we've already talked about as well. And again, this is sometimes beneficial as the expectation of an owner is the immediate protection of their floor, sustaining along with the polished appearance. So I think that the ability to utilize this polishing process, not only on new floors, but older floors as well, is a great benefit. And it's really amazing how an old, beat up, worn out concrete floor can really be brought back to life with the polishing process. And all the benefits of polishing we've already discussed, already talked about, apply to restoration of older floors as well. And many of the issues with older floors that we see listed here in the slide can be corrected. So here's a nice before and after shot. This is an old concrete floor with original vinyl asbestos tiles. And the grinding process was used to remove all the contaminants on the floor, and the polishing process was used to finish the floor. So this is a pretty dramatic example of what can be done to rehab an old slab and really bring it back to a usable life. Another benefit of polishing, reflectivity of the floor, can allow lower intensities of lighting, which can allow for reduced lighting costs. But this is kind of a unique case. In this instance, the contractor had polished the floor up to a high gloss finish. And, even though the owner loved the look, the amount of light entering the building and reflecting off of the floor caused it to be too bright. So they actually had to bring the shine back down a little bit, which doesn't happen very often. But again, that just goes to the amount of light reflectivity we can really achieve with this process. So slip resistance, this always seems to come up as a concern initially because the floor looks like it would be slick and easy to slip on, right? Well, that's not actually the case. In fact, it's just the opposite, and here's why. Let's say we have water on a floor, on a rougher surface that has not been polished. Well, a layer of water can sit in the low points or valleys of the concrete slab and cause a hydroplaning effect, which is actually more likely to cause someone to fall. And because a polished floor is very smooth, these valleys don't exist. And when you take a step on a polished floor, your shoe is in greater contact with the flat surface and you actually displace any water that might be under your foot. So as we see here, slip resistance of a polished floor actually exceeds OSHA and ADA requirements. So the takeaway here is to remember that a higher degree of polish is not directly related to slip resistance. Another misconception that is out there is that these floors are maintenance free, and that's not quite accurate. It's important to understand that while these are low maintenance floors, to be sure, a maintenance program or regular cleaning of the floor does need to be done. And because these floors are so flat, a layer of dust can act like ball bearings in a sense. So keeping these floors clean with regular, simple maintenance is important. So here's another great benefit. A ground and polished floor is smooth, which results in less wear on tires. So if you have, say, a warehouse or manufacturing facility where you have forklifts running around, this aspect alone can save you quite a bit of money over time. So as far as the timing of the polishing process, we mentioned this earlier. We want the concrete to be a minimum of 28 days old. And the densifier products used in the process are zero VOCs. So there's no problem with working on one area at a time while the building is occupied and in use. That's something we mentioned earlier in the presentation as well. And the densifiers comply with all current federal, state, and local maximum allowable VOC requirements, including US EPA. and the treated surface is USDA accepted. So this is a surprisingly cost-effective system, which we'll look at further in the next couple of slides here. So here's a cost comparison of polished concrete with some of the most popular flooring systems out there, like vinyl sheet goods, VCT floors, carpet, and epoxy floors. And this information comes from the National Terrazzo and Mosaic Association and looks at the 20-year cost of each system and includes the initial cost, replacement, and maintenance costs. And this analysis was done a number of years ago. So while all these costs have certainly increased, I think the comparative numbers still give us some very good insight. So let's start with the VCT floor. The installation cost is less expensive than other alternatives at approximately $1.23 per square foot. But the maintenance cost of these types of floors per year is expensive. Regular maintenance of these floors comes out to approximately $1.47 per square foot per year, according to our chart, for cleaning, waxing, etc. And the majority of these floors are required to undergo major maintenance or even replacement about every 15 years. So if we take this information from our chart and add up the cost for a 10,000 square foot VCT floor over a 20-year period, the cost over those 20 years comes out to approximately $340,000. So imagine what the cost of a 100,000 square foot building would be. Epoxy coatings are considerably more expensive than VCT floors to install at about $4 per square foot. And just like with the VCT floors, there is regular maintenance. And along with that, these floors need to undergo major maintenance or replacement, usually about every 6 years or so. So again, take the same square footage over 20 years and you're looking at a cost of over $240,000. By comparison, epoxy terrazzo floors are the most expensive to install, roughly around $9 per square foot. But the maintenance cost is low, just as with epoxy coatings. And the lifespan of an epoxy terrazzo floor is much longer than the traditional epoxy coatings. So this equates to a 20-year cost of just over $180,000. Now, with polished concrete, the installation cost falls between the previous two examples, approximately around the $5 to $6 per square foot range. But the maintenance cost of polished concrete is considerably less over the same time periods as the other alternatives, approximately around 50 cents per square foot per year. And as we mentioned earlier, there is some maintenance cost that has to be accounted for. But over the same 20-year period, by comparison, it's clear that the total cost for polished concrete is less than half the cost of several of the other alternatives and lower than any of them. This is basically the same information, just organized in a different way. Again, to just show you kind of what the cost comparisons would be of different systems. So a little different comparative chart here, basically showing the pros and cons of a concrete polishing system versus several other types of flooring systems. Pretty self-explanatory, really. We won't dive too much into this one, but if any of you would like to get any of these charts we've just looked at, let us know, and we can certainly get those to you. So just to recap a few things, this is a one-time application that will give us a long-lasting floor, and remember that maintenance, although minimal, is required. And you know, as with everything in construction, sustainable design is at the forefront, and all products and systems in some way affect this. Polished concrete has been developed to be a part of your sustainable design. And again, this is a bit of a recap, and I think we've covered most of these bullet points already. So how does polishing concrete assist with credit for LEED? Polished concrete can assist in the following areas: materials and resources, regional materials, indoor environmental quality, and low emitting materials. And more details can typically be found on most manufacturers' websites. So again, in terms of lead credits, the polishing process contributes in a large number of ways. Most of these we've discussed. So as we've seen, there are numerous benefits to utilizing the polishing process. So we've really covered quite a bit today in a short amount of time. We've looked at the process itself and all the steps involved. We've looked at the kind of projects where this type of system can be used. We've discussed both the functional and aesthetic results of choosing a polished concrete system for your floor, and we've looked at the comparative costs of installing a polished floor versus other flooring systems. So, as we said with our objectives earlier, we hope this presentation has given you a good overview of polished concrete and given you another great option to consider when you're designing and specifying your floor systems for your various projects. So this concludes the EIA portion of the presentation. And again, I want to thank all of you very much for attending and for your time today. I greatly appreciate it. Appreciate you all being with us. And we would certainly love to be your resource for all your building envelope needs. On this side, we have several ways you can contact us or source the information that you need. And let me mention that the toll-free 800 number you see there on the screen is good in all of North America, in the US and Canada. And that one number will connect you to the closest WR Meadows location to you. And other ways of getting in touch with us are listed here as well. And of course, our website. So we have lots of information available, as you can see here, and we constantly get compliments that our website is very user-friendly, which frankly I agree with. We've really tried to make it as easy as possible for you to contact us or to get access to the information you need as quickly and easily as possible. And the last thing I'd like to leave you with here, this is a convenient and very comprehensive sealer selector chart that we developed actually fairly recently. And I hope this flow chart will be a useful tool to help you simplify the process of trying to figure out the correct product or products that you need for a particular project. And again, if anyone would like access to this slide, simply let us know, and we'd be happy to send this to you. So with that said, that kind of completes my part of the program today. Again, thanks so much for being with us. We really appreciate your time.